If you were standing quietly on the surface of the moon, looking back across the vast, silent darkness of space, one sight would immediately draw your attention. Against the endless black, you would see a glowing blue world wrapped in soft white clouds, shining like a polished sapphire, suspended in the void. From that distance, it feels calm. It feels gentle, almost fragile, like a jewel floating alone in the cosmic night. But to a scientist who studies the universe, that peaceful blue sphere is more than beautiful. It is puzzling. It is unexpected. By everything we understand about physics and how planets form, that water should not be there at all. Earth is a planet covered nearly 70% by liquid water, and yet it orbits a star that burns like a colossal nuclear furnace. We exist in a region of the solar system where intense heat should have stripped away moisture long ago, billions of years in the past. By all reasonable expectations, Earth should resemble its neighbors, a dry, scorched rock like Mercury, or a cold, dusty desert like Mars. Instead, our world overflows with oceans. This water defines everything about our planet. It shapes the surface, regulates the climate, and forms the foundation of all known life. It is the cradle of biology itself, the quiet medium through which every living process unfolds. And yet its very presence remains one of the deepest and most debated mysteries in science. Where did Earth's water come from? Did it arrive from the heavens, delivered slowly by ancient comets, drifting in from the outer solar system? Did it emerge from deep within the planet, released from rocks, as Earth cooled and changed? Or is it something even older? A lingering remnant from a time before Earth itself had fully formed. Tonight, we will gently trace the story of the oceans. We will journey back to an age of fire and molten rock, through the era of endless rains, and slowly uncover the hidden history behind the water that now rests quietly in your glass. Before we begin, take a moment to get comfortable. If you enjoy these calm explorations of science and space, you're welcome to like the video and subscribe. And if you feel like it, let me know in the comments where you're listening from and what time it is for you. It's always peaceful to imagine this journey being shared across different corners of the world. Now dim the lights. Perhaps turn on a fan, letting its gentle hum fade into the background. Settle in and let's ease into tonight's journey together. To understand why Earth's oceans are such a profound mystery, we first need to look outward toward our planetary neighbors. The inner solar system is a harsh place, a realm shaped by heat radiation and relentless energy. Mercury, closest to the sun, is a blistered world of bare rock and metal, scorched and airless, endlessly exposed to solar radiation. Venus, nearly Earth's twin in size, tells an even darker story. Its thick atmosphere traps heat so efficiently that surface temperatures soar high enough to melt lead, erasing any trace of water that may once have existed. Farther out, Mars stands cold and quiet, a frozen desert where water survives only as ice at the poles or locked deep beneath the surface, a faint memory of a wetter, warmer past. And then there is Earth. We are the exception. Earth is the only planet we know of where water exists naturally in all three states at once: solid ice, invisible vapor, and most importantly, flowing liquid. We are a water world thriving in a region of space that is fundamentally hostile to water's existence. The sheer quantity of it is astonishing. More than 1.3 billion cubic kilometers of water blanket the surface. It fills deep ocean basins, carves vast canyons, rises into the atmosphere, and circulates quietly through every living organism. This abundance does not fit neatly into our standard models of how planets are supposed to form. In the early days of the solar system, everything emerged from a violent, swirling disk of dust and gas surrounding the young sun. Close to that newborn star, temperatures were simply too high for water to condense. Any moisture should have remained as vapor pushed outward by solar winds toward the colder edges of the system. Earth formed in this dry inner region. It was built from parched rock under intense heat. By all logic, it should have remained dry. So when you gaze across the Pacific Ocean, you are looking at something that, in theory, should not exist at all, an alien substance that somehow found a home where it does not belong. To understand how it arrived here, we must look to a subtle, invisible boundary that divides our solar system in two, a line that quietly shaped the fate of Earth's water and perhaps life itself. Astronomers have discovered that our solar system is quietly divided by an invisible boundary, a thermal threshold known as the frost line, sometimes called the snow line. It is not a physical wall, but a change in temperature, and its effect is simple and profound. Imagine standing near a small campfire on a cold night. Close to the flames, the air is warm, and snow cannot survive. Ice melts instantly, becoming vapor. But as you step farther away into the darkness, there comes a point where the warmth fades. Beyond that distance, snow can exist, settling quietly on the ground. The frost line works in much the same way. In the early solar system, this boundary lay somewhere between the orbits of Mars and Jupiter. Inside this line, temperatures were too high for water to remain solid. Any water existed only briefly as vapor before being driven away. Mercury, Venus, Earth, and Mars all formed within this inner dry region, under the relentless heat of the young sun. Here, volatile substances like water could not survive. The dust grains that gradually clumped together to build the rocky planets were stripped of moisture, composed mostly of metal and stone. These were dry ingredients shaped by heat and radiation. Beyond the frost line, however, conditions were very different. Farther from the sun, in the colder reaches of the system, where the gas giants formed water, was plentiful. It froze into hard, crystalline ice, collecting into vast reservoirs of comets, icy moons, and frozen debris. Out there, water was not rare. It was abundant. And yet, Earth exists on the wrong side of this invisible divide. By the rules of planetary formation, our planet should have remained dry built from the parched dust of the inner solar system. And still, it is covered in water that seems to belong far beyond its birthplace. The birth of Earth itself was anything but calm. It was not a gentle gathering of material, but a violent and chaotic process. About 4.5 billion years ago, the young planet grew through accretion, a relentless series of collisions. Asteroids, planetesimals, and fragments of rock slammed together, again and again, their gravity pulling them into an ever-growing sphere. Each impact released enormous amounts of energy instantly converted into heat. The early Earth was not merely warm, it was molten. In this intense forge of creation, even if small traces of water had been locked inside the original rocks, the heat of accretion would have driven it out. Any moisture would have escaped as steam rising into the atmosphere, only to be stripped away, by the fierce solar wind of the newborn sun, a star far more violent and active than the one we orbit today. According to the Standard Model, the infant Earth was completely dry, a sterile world of glowing magma orbiting within a cloud of dust. It had a dense iron core and a rocky mantle, but it lacked the fragile, volatile ingredients needed for life. It was a planet without oceans, without rivers, without even a single drop of blue. To understand this moment more clearly, we must travel back to the earliest chapter of Earth's history, the Hadean Aeon. Its name comes from Hades, the underworld of Greek mythology, and the description is fitting. If you could observe Earth 4.5 billion years ago, you would not recognize it. There were no continents, no green landscapes, no seas. The surface was a global ocean of molten rock, glowing and restless, slowly radiating heat into the surrounding darkness of space. The sky above this magma ocean was not blue. It was likely thick and hazy, tinted orange or red, filled with carbon dioxide, nitrogen, and vaporized rock. Atmospheric pressure would have been crushing. The environment was hostile beyond imagination. In this burning world, liquid water was impossible. Any molecule of H2O that reached the surface would have instantly flashed into steam, rising upward and vanishing into space. This was Earth at its beginning, a planet defined by fire, by heat, and by the complete absence of the liquid that would one day shape its destiny. And yet, even as we picture this glowing sphere, we know something extraordinary was about to unfold. Somehow this world of fire would cool. Somehow dry rock would become wet. And somehow oceans would appear where none should exist. The transformation from that Hadean world of fire into a planet of oceans is the greatest metamorphosis the solar system has ever known. Nothing else comes close. Just as the young Earth began to cool, just as a thin, fragile crust may have started to form on its surface, the universe delivered an event so violent that it erased all progress in an instant. This is known as the giant impact hypothesis. It suggests that around 4.5 billion years ago, Earth was not alone along its orbit. Nearby traveled another planetary body roughly the size of Mars, a world scientists now call Theia. Their paths were destined to cross. When they finally collided, the force released was beyond anything we can truly imagine. This was not a simple collision. It was a merger. The impact liquefied the planet completely, blasting trillions of tons of molten rock into space. A vast ring of fire formed around Earth debris that would eventually come together to create the moon. But for the story of water, this moment was catastrophic. The heat generated by the impact was so extreme that it stripped Earth of any atmosphere it may have briefly held. If there had been shallow seas, damp rock, or even trace amounts of surface moisture, they were erased instantly. Water molecules were torn apart, vaporized, and hurled into the vacuum of space, never to return. Earth was left spinning, destabilized, and utterly dry. The giant impact was a cosmic reset button. It ensured that our planet's story would begin again, from absolute dryness. When the violence finally subsided, a deep silence settled over the solar system. The debris gradually cleared. The moon found its orbit, and Earth began a slow, patient process of recovery. The global ocean of magma, once blindingly bright, started to cool. Heat radiated outward into space. Over time, the surface darkened. Temperatures fell. A fragile skin began to form atop the molten interior. This was Earth's first crust. It was likely a broken, jagged landscape of basalt and obsidian, black, brittle, and unstable. Cracks opened, constantly slabs sinking back into the glowing mantle below. Imagine a world made of dark glass beneath a faint, distant sun. There was no wind, because there was barely an atmosphere. There were no waves, no water to move. The only sounds, if sound could exist at all, would have been the subtle ticking of cooling rock and the deep, slow rumble of the planet's interior. It was a silent world, a dry world, almost colorless. The vessel was ready. The cup had been formed, but it was empty. Earth was now prepared to hold water, but it could not create it on its own. The water would have to come from somewhere else. It would have to be delivered. And around 3.9 billion years ago, that delivery began. At that time, the solar system was far from stable. The giant planets Jupiter and Saturn were still migrating, slowly shifting their orbits in a complex gravitational dance. Their immense gravity disrupted the quiet balance of the system, acting like colossal slingshots. Millions of asteroids and comets long stored in the frozen outer regions were thrown inward. Their paths bent toward the sun and directly across Earth's orbit. This chaotic era is known as the Late Heavy Bombardment. For millions of years, the sky fell. Earth was relentlessly struck by cosmic debris. These were not small meteors burning harmlessly in the atmosphere. These were massive mountain-sized bodies of rock and ice impacting the dark crust with energies comparable to nuclear arsenals. From the surface, the night sky would have been a constant storm of light, streaks, flashes, and explosions tearing across the darkness. It looked like destruction, but it was not disaster. It was delivery. These impactors were carriers, cosmic freighters transporting the very materials Earth lacked. They brought volatile compounds, frozen gases, and most importantly, vast quantities of ice. With each impact, a little more water was released. Slowly, over immense stretches of time, the black planet began to change. The rain that would one day fill the oceans had begun to fall not from clouds, but from the depths of space itself. When scientists first began searching for the origin of Earth's water, their attention naturally turned outward toward the cold edges of the solar system. Far beyond Neptune, drifting slowly through darkness, are the comets, ancient wanderers left over from the birth of the sun itself. These objects are often described as dirty snowballs. They are mixtures of frozen gas dust and water ice preserved from the earliest days of planetary formation. When a comet falls inward toward the sun, heat awakens it. Ice turns to vapor, and a luminous tail unfurls across space, visible proof that water is locked deep inside. For many years, this led to an elegant and appealing idea. During the late heavy bombardment, countless comets would have crossed Earth's path. Each impact could have delivered vast amounts of ice instantly melting or vaporizing on contact, feeding a growing, steam-filled atmosphere. Over time, that vapor could condense rain down and slowly fill the oceans. It was a beautiful thought. The idea that Earth's seas are melted comets, that the water in our bodies once drifted through the coldest reaches of space. In this picture, Earth was simply a dry vessel, patiently filled by a cosmic hose. But in science, beauty is not enough. Evidence must follow. To test this idea, scientists needed more than imagination. They needed to compare Earth's water to the water found on comets themselves. They needed, quite literally, to taste them. Water, after all, is not always identical. Sometimes the hydrogen atom carries an extra neutron, becoming deuterium, a heavier form of hydrogen. The ratio between normal water and this heavier variety acts like a chemical fingerprint. It reveals where the water formed and under what conditions. In 2014, a spacecraft named Rosetta achieved something extraordinary. After a 10-year journey through space, it caught up with a comet known as 67P. Rosetta released a small lander onto its icy surface, allowing scientists to analyze the escaping vapor directly. The results were startling. The water on the comet was heavy, far heavier than the water in Earth's oceans. Its deuterium ratio was nearly 3 times higher. The fingerprints did not match. If Earth's oceans had come primarily from comets, like this one, our planet's water chemistry would look very different. The romantic theory quietly collapsed. Comets, it seemed, may have contributed a drizzle here and there, but they were not the source that filled the basin. The true carriers of Earth's water had to be something else, something far less dramatic. Attention shifted inward from icy comets to their quieter cousins, asteroids. In particular, scientists began studying a class known as carbonaceous chondrites. To the eye, these space rocks appear unremarkable dull dark stones without ice or glowing tails. But space is often deceptive. These asteroids are more like cosmic sponges. Their minerals are rich in hydrated clays structures that trap water molecules within their crystalline lattice. Though the water is not visible as ice or liquid, it is chemically bound inside the rock itself. Some of these asteroids can contain up to 20% water by weight. They formed closer to Earth within the asteroid belt, a region cold enough to preserve water, but not so cold that it froze into pure ice. During the bombardment, trillions of these damp rocks likely fell toward Earth. They did not arrive as oceans or glaciers, they arrived as stone. But with every impact, heat released the trapped water, turning it into steam. Slowly, relentlessly, that steam accumulated, not as a sudden flood, but as a gradual infusion. Meteor by meteor, pebble by pebble. The oceans were delivered as hydrated dust. This idea is known as the late veneer theory. It suggests that Earth's blue surface is in a sense a final coating, a thin, wet layer, applied after the planet itself had finished forming. For a long time, the story of water was told as a story of delivery. Earth was assumed to be dry at birth, waiting to be filled from the outside. But in recent years, a quieter and more radical idea has emerged, one that challenges that assumption entirely. What if the water never arrived from the sky at all? What if it was already here? This is known as the inside job hypothesis. It proposes that the dust grains that came together to form Earth were not completely dry. Even in the warm inner solar system, water molecules may have clung to minerals locked into the chemical structure of the dust itself. If so, then as those grains merged into rocks, and rocks into a planet, the water was buried deep within, hidden, protected. As Earth grew, gravity crushed the material, inward sealing that water into the mantle thousands of kilometers beneath the surface, trapped under immense heat and pressure. In this view, the oceans are not a foreign coating. They are Earth's own breath, slowly released over billions of years as the planet cooled, cracked, and exhaled the moisture it had carried since its earliest moments. It changes how we see the ground beneath our feet. Solid rock is not a barrier to water. It may be the greatest reservoir of all. At first, this idea seems almost impossible. How could solid rock hold water, especially deep inside Earth, under crushing pressure and intense heat? It sounds like a contradiction. Stone feels dry, water feels fluid. The two seem fundamentally opposed. To test this idea, scientists needed to recreate one of the most extreme environments on Earth, the planet's deep mantle. They did this using a remarkable device known as a diamond anvil cell. Tiny samples of mineral were placed between the tips of two flawless diamonds. Then, with extraordinary force, the diamonds were pressed together. Pressures equivalent to those found hundreds of kilometers beneath the surface were achieved. At the same time, powerful lasers heated the samples, mimicking the scorching temperatures of Earth's interior. What happened next changed geology. Under these conditions, the minerals did not simply crack or melt. Instead, their internal structure transformed. They rearranged themselves into new high-pressure form structures that acted like microscopic cages, And within those cages, there was space for hydrogen and oxygen. The experiments revealed something astonishing: rock, under sufficient pressure, behaves like a sponge. It can absorb and store water within its crystal lattice. It does not become soft. It does not appear wet. It remains solid stone. But chemically, it is saturated. This discovery opened a door to a hidden world, the possibility of an immense reservoir of water locked deep within the earth itself. The strongest evidence for this idea came from an unlikely messenger, a diamond carried to the surface by a volcanic eruption from the deep mantle. Trapped inside that diamond was a tiny impurity, a grain of a mineral called ringwoodite. Ringwoodite forms only at depths between roughly 400 and 600 kilometers below the surface, in a region known as the mantle transition zone. When scientists analyzed this small blue speck, they found something extraordinary. It contained water. About 1.5% of its weight was made up of water molecules locked into its structure. On its own, that number seems modest. But the scale of the transition zone is immense. If much of that region is composed of ringwoodite, and if it holds water in similar amounts, the implications are staggering. The calculations suggest that deep within Earth, there may be enough water to equal 3 times the volume of all the oceans on the surface combined. We are floating on a hidden sea: the Pacific, the Atlantic, the Indian Ocean. These vast bodies of water may be only the overflow thin puddles resting on the surface. The true ocean lies far below, solid and hot, buried hundreds of kilometers deep, locked inside crystals of blue mineral. So how did any of this deep water ever reach the surface? The answer is heat. The young Earth was a restless and violent world. Its interior churned with radioactive energy and the lingering heat of formation. That energy drove volcanic activity on a scale almost impossible to imagine today. Millions of volcanoes' vents and fissures opened across the cooling crust. As molten rock rose from the mantle toward the surface, pressure dropped, and as that pressure was released, the water trapped inside the crystal structure of deep rocks was freed. It flashed instantly into steam. For millions of years, Earth's volcanoes did more than pour out lava. They breathed, they exhaled, they pumped enormous volumes of gas into the sky. Water vapor, carbon dioxide, nitrogen, building a thick, heavy atmosphere around the planet. The rain had not yet begun, but the air was filling, and the stage was being quietly set for the moment when steam would finally cool, condense, and fall, turning a dry black world into a planet of oceans. This period is known as the Great Outgassing. Earth was in a very real sense sweating its oceans into the sky. The water had finally left the rock, but it had not yet reached the ground. Instead, it hovered above the planet, forming a vast global envelope of steam. The atmosphere thickened. Clouds grew dense and heavy. Everything was in place for rain, but the rain could not yet fall. The planet had to wait. Earth was trapped in a long, suffocating pause. The atmosphere was nothing like the thin, transparent veil we know today. It was a crushing blanket of water vapor, carbon dioxide, and volcanic gases. Surface pressure may have been hundreds of times greater than it is now. The planet had become a pressure cooker on a global scale. In this environment, there was no weather as we understand it, no winds, no seasons, only uniform brightness. The sun was invisible, reduced to a dull, diffuse glow behind miles of superheated temperatures remained dangerously high, sustained by a runaway greenhouse effect created by the steam itself. This was a world in suspension. The water was present, billions upon billions of tons of it, but it was trapped in the sky, unable to return home. Earth was locked in a quiet standoff between the cold vacuum of space and the radiating heat of its molten surface, a planet holding its breath, waiting for the fever to break. And slowly, inevitably, it did. Heat leaked away, radiating outward into the darkness. Over time, the upper atmosphere began to cool. It passed a critical threshold. The water vapor molecules, which had vibrated with restless energy for millions of years, began to slow. They drifted closer together. They clustered. They condensed. High above the surface, the first clouds formed. These were not the soft, drifting clouds of a summer sky. They were massive, heavy storm systems, dark, bruised clouds stretching across the entire planet. And then at last it happened. A single droplet of water condensed around a grain of volcanic dust. It grew heavier, heavy enough to overcome the rising currents of hot air below, and it began to fall. It fell through kilometers of steam, enduring the heat until it struck the black, jagged surface of cooling basalt. It did not splash. The ground was still too hot. The droplet met the rock with a violent hiss and instantly flashed back into vapor. For centuries, this was the pattern. Rain that never reached the ground. Phantom rain. A cycle of condensation and evaporation, repeating endlessly, but the rock was losing its struggle. Each droplet that struck and vanished carried away a tiny fraction of heat. Drop by drop, hiss by hiss, the surface cooled, and then finally one drop landed and stayed. It was the turning point. The end of the dry world had begun. Once this cycle tipped, it did not stop. What followed was the Great Deluge, a storm beyond any human comparison. This was not rain measured in days or seasons. Geological models suggest that once the atmosphere collapsed, rain may have fallen continuously for 10,000 years, perhaps even 1,000,000. It was a deluge of unimaginable scale. Imagine the sound, the relentless roar of water striking stone, unbroken by silence. Century after century, day and night, lost all meaning. Lightning would have torn constantly through the steam-choked sky, illuminating a surface being reshaped in real time. This rain was not gentle. It was hot, and it was acidic. As the water fell through the carbon-rich atmosphere, it absorbed carbon dioxide, forming carbonic acid. It did not merely wash the rocks, it dissolved them. Mountains were etched away, valleys were scoured, salts and minerals were stripped from the crust in a violent chemical cleansing. This was a planetary baptism, a final erasure of the Hadean world. And where did all this water go? At this time, Earth had no continents, as we recognize them. There were no wide plains or stable mountain ranges to guide the flow. The surface was chaotic, a broken landscape of volcanic peaks and immense impact basins left behind by ancient collisions. The rain had only one place to collect, downward, into the deepest scars of the planet. The water obeyed the simplest rule in the universe. It flowed downhill. Thin trickles became streams. Streams merged into fast-moving channels of hot gray slurry. And those channels grew into rivers. They surged across the broken surface, carrying heat minerals and dissolved rock toward the deepest scars of the planet, the vast basins left behind by ancient impacts. At first, the water gathered only in small places. Shallow, steaming pools collected at the bottoms of craters. They hissed and boiled at the edges, but the rain did not stop. The puddles spread. They connected. They deepened. Slowly, the rising water swallowed the land. Lava fields disappeared beneath the surface, cooling rapidly into rounded formations known as pillow basalts, rock shaped by fire meeting water. Black stone vanished beneath an ever-thickening gray veil. The magma ocean was gone. In its place, a water ocean was taking form. And when the clouds finally began to thin, when sunlight at last pierced the fading veil of steam, it shone not on a red burning planet, but on something entirely new. A world of scattered volcanic islands, rising from a global steaming sea. Eventually the rain ceased. The clouds broke apart, light returned to the surface. But the world revealed was not yet the Earth we recognize. If you could have stood on one of those lonely volcanic peaks 3.5 billion years ago, you would have gazed out over an alien ocean. The water was not blue. It was dark, murky, and tinged with olive green. The sea was rich in dissolved iron. In our modern world, oxygen in the air reacts with iron, turning it into rust that sinks to the bottom. But in this early, Earth-free oxygen did not yet exist. The iron remained suspended in the water, giving the ocean a metallic taste and its deep green hue. The sky above was likely no blue either. It would have appeared hazy pinkish or orange-colored by thick concentrations of methane and carbon dioxide. It was a landscape of unfamiliar colors. A green sea beneath an orange sky, hot, heavy, and utterly hostile to the life that would one day emerge. The water itself was scalding. Surface temperatures may have approached the boiling point, turning the global ocean into a vast steaming bath. But perhaps the most striking feature of this early water world was what it lacked. There were no continents. The massive land masses we know today, Africa, Asia, the Americas had not yet formed. The granite that makes up continental cores is a lighter rock buoyant atop the mantle. But creating it requires billions of years of tectonic recycling, melting, and separation. In the Hadean and early Archean eons, this process was only beginning. Earth was truly a water world. A single unbroken ocean covered 95, perhaps even 99% of the planet. The only land consisted of chains of dark volcanic islands, resembling modern Hawaii or Iceland, rising briefly above the waves before sinking again. With no continents to block their flow, ocean currents were ferocious. They raced around the equator in uninterrupted loops. The tides were extreme, pulled by a moon that orbited much closer than it does today. Twice a day, massive waves scoured the volcanic islands, tearing debris loose and dragging it back into the depths. It was a restless world, a machine of water and stone constantly in motion. The rain that created this ocean was fresh. It was distilled water formed from pure steam. So why then is the ocean salty? The salt did not fall from the sky, it came from the rock. The early atmosphere was thick with carbon dioxide and sulfur-bearing gases. As rain fell through this air, it became acidic, charged with carbonic and sulfuric acids. When this acidic rain struck the volcanic islands, it attacked the rock with chemical intensity. Mineral bonds broke apart. Ions were freed: sodium chloride, calcium, magnesium. These dissolved into the water and were carried downhill by rivers into the sea. This process continues even today. For billions of years, rivers have acted as a slow conveyor belt, stripping the land of its minerals and delivering them to the ocean. Water evaporates, rises, and falls again as rain, but the salt remains behind. It accumulates. Over vast spans of time, this invisible chemical weathering transformed the fresh acidic floodwaters of the early Earth into the salty alkaline oceans we know now. Every cup of seawater contains the dissolved memory of mountains that vanished long ago. The ocean is not just water, it is a liquid fossil of the land. And to understand what this new global ocean truly became, to find its deeper purpose, we must descend beneath the surface. We must leave the storm-battered, radiation-soaked world above and sink slowly into the silent, crushing darkness of the abyss. Down along the fractured seams of the ocean floor, where the crust grows thin and molten rock, rises close to the surface, we encounter a place where two worlds meet. This is the boundary between the geosphere and the biosphere, between stone and life. Here, in total darkness, are the hydrothermal vents. They rise from the seafloor like chimneys, tall mineral towers, releasing dark plumes into the surrounding water. At first glance, it looks like smoke, but it is not smoke at all. It is water. Seawater that has seeped deep into the crust, been heated by magma, enriched with minerals, and forced violently back upward. This is where fire and water shake hands. Among these vents is a rare and remarkable type known as the lost city fields. Here, the conditions are gentler. The water is warm rather than scorching alkaline, instead of acidic and rich in hydrogen gas. It seeps slowly upward through microscopic, honeycomb-like chambers in the rock. These chambers act like tiny laboratories. Inside this warm, mineral-rich darkness, sheltered from the chaos of the surface world, something extraordinary is happening. The water is not merely flowing. It is organizing. It is guiding chemistry towards structure. Water here is not a passive background. It is the active ingredient. In the Hadean and Archean oceans, water acted as the universal solvent. It dissolved minerals released from the vents. It captured carbon-rich dust falling from asteroid impacts. It absorbed reactive gases energized by lightning from the atmosphere. It gathered chaos and blended it into a single planetary solution. This mixture is often called the primordial soup, but soup suggests disorder. Water does something more subtle than mixing. Within the microscopic pores of hydrothermal vents, water surrounded fragile organic molecules, shielding them. It allowed them to concentrate instead of drifting apart. Amino acids, the building blocks of proteins, were able to link together. Fatty acids assembled into bubbles, forming the earliest precursors of cell membranes. This was not a single moment of creation. It was billions of experiments played out silently over immense spans of time. A chemical lottery repeated again and again in the dark. Water provided the safe harbor, the temperature buffer, and the transport system that allowed molecules to meet, interact, and eventually copy themselves. The ocean was not just water, it was a planetary womb. And this raises a deeper question. Why water? Why is life on Earth not built upon liquid methane or ammonia or silicon? The answer lies in the strange and subtle physics of the water molecule itself. Water is a dipole. Each molecule has a slight positive end and a slight negative end, like a tiny magnet. This allows water to dissolve a wide range of substances, breaking nutrients apart so they can be transported. But more importantly, it allows structure to emerge. Consider DNA, the spiraling ladder that stores the code of life. DNA holds its shape through interactions with water. Parts of the molecule repel water and curl inward. Other parts attract it and face outward. The famous double helix is sculpted by the water surrounding it. Without water's constant push and pull, DNA would unravel. Proteins, too, fold into their precise working shapes only because of how they interact with water. Life at its core is a delicate choreography of molecules suspended in H2O. We are not simply creatures that drink water. We are creatures made of water, organized by water, sustained by the unusual behavior of this one simple molecule. The ocean did not merely give rise to life. It still lives inside us, holding our cells together, guiding every reaction, shaping every breath. Water feels ordinary to us. It fills our glasses, it falls from the sky, it surrounds us every day. But to a chemist, water is deeply strange. By the strict rules of chemistry, liquid water should not exist here at all. H2O is a small, light molecule. Based on its size and mass, it should behave like its chemical cousins methane or ammonia, existing as a gas at room temperature. On a planet like Earth, water should have either boiled away into vapor or frozen solid long ago. There should be no liquid middle state. And yet water cheats. It remains liquid because of a rare and powerful property called hydrogen bonding. Water molecules are sticky. The hydrogen atoms of one molecule are gently attracted to the oxygen atoms of another. These fleeting attractions form a shifting, invisible web, a ghostly grip that holds the molecules together against their tendency to drift apart into gas. It is this quiet molecular embrace that keeps oceans' liquid cells intact and life possible. A simple molecule, holding together an entire living planet. This invisible web of attraction between water molecules is what gives water its surface tension strong enough to let insects rest lightly upon it. It is also what allows water to remain liquid across an unusually wide range of temperatures. Without this subtle molecular grip, the oceans would slowly evaporate. Our blood would boil, and Earth would be wrapped in a dry, poisonous haze. But water breaks another rule as well, a rule so fundamental that we rarely stop to question it. In the physical world, most substances contract as they cool. Their molecules pack closer together. They grow denser. Solid rock sinks into molten rock. Solid iron sinks into molten iron. Water does the opposite. As water approaches its freezing point, its molecules arrange themselves into a rigid, hexagonal crystal pattern. To fit into this structure, they must spread apart. Ice becomes less dense than liquid water. It expands. It floats. This quiet anomaly may be the single most important reason life exists on Earth. Imagine if water behaved like everything else. Ice would sink. Each winter, ice forming at the surface of the ocean would fall into the depths, stacking layer upon layer beyond the reach of sunlight. The oceans would freeze from the bottom up, eventually locking away all liquid water. Life would be crushed or frozen into extinction. But ice floats. It forms a skin on the surface, a thin, fragile blanket that insulates the water below. Heat is trapped beneath this layer, keeping the deep ocean liquid and stable, even during the most extreme ice ages. In the coldest moments of Earth's history, life endured because water refused to follow the rules. Water's third quiet miracle is its relationship with heat. Water has an exceptionally high heat capacity. It is stubborn. It takes an enormous amount of energy to warm it. And once warmed, it releases that heat only slowly. Rock behaves very differently. In dry deserts where water is scarce, temperatures swing violently, scorching by day, freezing by night. But the oceans act as a planetary stabilizer. They are a thermal battery. During the day, they absorb the sun's energy without boiling. At night, they release that stored warmth gradually into the atmosphere. Without this buffering effect, Earth would be a world of lethal extremes: an oven at the equator, a deep freeze at the poles. Ocean currents act as the planet's plumbing system. Warm water is carried from the tropics toward higher latitudes, while cooler water returns southward. This slow circulation redistributes heat, creating the temperate zones in which we live. We exist inside a carefully balanced climate, protected from the emptiness of space by the quiet thermal memory of water. And yet the ocean is not as permanent as it appears. The seafloor is not a static basin. It is a moving conveyor belt. At the deepest trenches, places like the Mariana Trench, Earth's tectonic plates collide. One plate slides beneath another and sinks into the hot, slowly flowing mantle below. This process is called subduction. And as the rock descends, it carries the ocean with it. The water does not drain away like liquid down a hole. It is chemically bound inside the crust itself. Over millions of years, the rocks of the seafloor become saturated, hydrated under immense pressure. When these massive slabs plunge into the mantle, they drag trillions of tons of water downward with them. Recent seismic studies suggest that at the Mariana Trench alone, far more water is being pulled into the earth than scientists once believed. It is a slow, silent loss. The planet is drinking its own oceans, returning them to the deep reservoir from which they likely emerged billions of years ago. But Earth is not a tomb, it is a cycle. What descends does not remain buried forever. As subducted rock heats up in the mantle, the water locked inside is squeezed free. It rises again, mixing with molten rock, fueling explosive volcanoes along the ring of fire. Sometimes it returns in an even stranger form. On the floor of the Pacific Ocean, there are mountains that do not erupt with flame, they erupt with mud. These are cold seep mud volcanoes, towering structures formed by the release of pressurized water and crushed rock from deep within subduction zones. They are vents in Earth's internal plumbing system, releasing fluids that have been trapped underground for eons. This water has traveled through the heart of the planet. The cycle from rain to ocean to mantle, and from mantle back to the surface is slow unfolding over tens and hundreds of millions of years. But it is constant. It regulates the planet over geological time, ensuring that even as surface oceans rise and fall, Earth itself never truly runs dry. Water came from fire. It shaped stone. It gave rise to life. And it continues to move quietly, patiently, through the living body of the planet, binding Earth's past, present, and future into a single flowing whole. This deep reservoir of water does more than circulate quietly through the planet. It performs a vital function, one that keeps Earth alive and dynamic. Geology tells us that plate tectonics, the drifting of continents, the rise of mountains, the recycling of crust, is something uniquely active on Earth within our solar system. Venus, our planetary twin in size and composition, tells a very different story. Its surface is locked beneath a single unbroken shell of rock. There are no moving plates, no drifting continents. Why the difference? Once again, the answer is water. Deep within Earth's crust and upper mantle, water acts as a planetary lubricant. Water molecules weaken rock. They lower melting points. They reduce friction along immense boundaries of stone. Without water, Earth's crust would be dry, rigid, and immobile. The continents would freeze in place. Carbon would no longer be recycled. Volcanoes would fall silent. The planet would become geologically still, a stagnant world, much like Venus. It is water slipping quietly through the deep earth that keeps the gears turning. The ground beneath our feet moves only because it floats atop rock that is softened, made flexible by hidden moisture. The ocean is not merely a habitat for life. It is the engine oil of the planet. To fully appreciate how unusual Earth's open oceans are, we need to look beyond our world to the competition. For a long time, we believed Earth was the only water world in the solar system. That belief has quietly faded. There are other oceans out there. They are simply hidden. Orbiting Jupiter is Europa, a moon wrapped in fractured white ice. Around Saturn drifts Enceladus, a small, gleaming snowball. To the eye, these worlds appear cold, silent, and lifeless. But gravity tells a deeper story. As these moons circle their massive parent planets, they are stretched and squeezed by powerful tidal forces. This constant flexing generates heat deep within their interiors. That heat melts ice from below. Beneath Europa's miles-thick shell of solid ice lies a vast liquid ocean, a salty sea that may be tens of kilometers deep, holding more water than all of Earth's oceans combined. It is warm, it is rich in minerals, and it is completely sealed off. This is a stealth ocean, one that exists in permanent darkness, cut off from the sky, the stars, and the atmosphere. A sea trapped beneath ice, protected, pressurized, and hidden. And this comparison reveals something profound about Earth. In the universe, liquid water seems to prefer concealment. Underground oceans may be common. Water locked beneath ice or rock may be the rule rather than the exception. But a surface ocean, an exposed ocean like ours, is rare. Earth's water lies open to the sky. It interacts with wind to create waves. It evaporates to form clouds. It falls again as rain. It reflects sunlight back into space. This openness makes our planet vulnerable. Without a thick shell of ice for protection, Earth's oceans depend entirely on a delicate balance. The atmosphere to regulate temperature and the magnetic field to shield the planet from the solar wind. Tip that balance too far, and the oceans could boil away or freeze solid. We are walking a narrow line. And yet it is this exposure that gives our oceans their power. The Pacific and the Atlantic are not just bodies of water. They are the planet's lungs, exchanging gases with the air, driving climate-shaping weather, and creating sunlit dynamic environments. In these restless waters, complex life learned to see, to sense light, to recognize horizons. Life beneath the ice of Europa may exist, but it would never know the sky. It would never experience a sunrise, a wave, or the shimmer of reflected starlight. Earth's oceans are dangerous, fragile, and exposed. And because of that, they are alive. The story of water does not end with the geology of the planet. It continues inside you. When life first left the ocean and ventured onto dry land hundreds of millions of years ago, it faced a crisis. It was leaving its birthplace. On land, the air is dry, the sunlight is harsh. To survive, life had to do something extraordinary. It had to bring the ocean with it. Life internalized the environment it came from. And you are the vessel that carries that ancient sea forward. The human body is made of water, not fresh water, but salt water. Your blood, your sweat, and your tears all carry a salinity strikingly similar to the early oceans where life first learned to exist. We never truly left the sea. We simply built suits of skin and bone to move across dry land while keeping the water inside. Every time your heart beats, it pushes a carefully balanced version of the Archean Ocean through your veins. We are walking aquariums, breathing reminders of the deep past. If you look closer beyond organs and tissues, down to the scale of a single cell, the truth becomes even clearer. Inside each cell is cytoplasm, a soft, watery gel, a microscopic ocean. The machinery of life does not work in emptiness or solidity. DNA proteins, mitochondria, they all float. They move, fold, and function only because they are suspended in water. A protein finds its precise shape because of how water presses and releases it. A nerve signal travels as ions flowing through a watery channel. In the most literal sense, life is an organized motion of water. Without it, the dance stops. Dry land is an illusion. At the cellular level, we are still swimming. Now consider the water in the glass beside your bed. It looks simple, clear, ordinary. But every drop carries a history as old as the solar system itself. That water was forged in the aftermath of dying stars, frozen in the cold outskirts of the early solar nebula, and carried to Earth inside ancient rock during the Great Bombardment. It has cycled through this planet for 4.5 billion years. It has been steam in a choking Hadean sky. It has been ice grinding continents flat. It has passed through the body of a dinosaur and the leaves of a giant fern. It has been dragged into the mantle and exhaled again by volcanoes. The water you drink is not new. It is endlessly recycled, purified by evaporation and rain, refined by time itself. You are drinking the same molecules that once fell onto the cooling crust of the infant Earth. Water is the only witness to the entire story. But even this story will not last forever. Earth is mostly closed but not perfectly sealed. High above where the air thins, ultraviolet light from the sun tears water molecules apart. Oxygen remains, but hydrogen light and fast escapes into space. This slow loss is called atmospheric escape. Second by second, the planet leaks. Over billions of years, the oceans will thin. As the sun grows brighter with age, this process will accelerate. One day the seas will boil away, the atmosphere will fade. Earth will become dry and silent like Mars or Venus. The blue marble is temporary. This is the golden age of water. But that ending lies unimaginably far ahead. For now the cycle holds. The sun warms the ocean, water rises as vapor, clouds form. Rain falls. It is the heartbeat of the biosphere. Listen to the sound of rain against the window. That sound has echoed on this planet for 4 billion years. It is the sound of hot rock cooling, the sound of the ocean returning to the land. We are drawn to it instinctively. Waves, rainfall, flowing streams. Perhaps because deep down it is the sound of home, we are creatures of water. Exiles from the sea, walking on dry ground, carrying an internal ocean within us. When we hear water, something ancient remembers. And so the story of water's origin comes full circle. We have followed a single drop from the violence of star birth to the quiet glass beside your bed. The cycle closes. For many of you, the rhythm of this journey may already be doing its work. The sound of eternal rain may be guiding you into deep, dreamless sleep. If you are drifting now, let go, you are safe. But perhaps you are still awake. Perhaps the silence has not fully settled. If you are still listening, if your mind is wandering gently in the dark, then we can remain here a little longer. Because there is another story. We have spoken about the water, but we have not spoken about what lies beneath it. There is a mystery, not in the ocean itself, but below it, hidden, forgotten, and buried deep within the earth. So if you are still with me, let's stay in the dark a little longer. Our search for the lost lands begins far from shore in the vast and seemingly empty blue of the South Pacific. On an ordinary map, you see Australia, and far to the east, the islands of New Zealand. Between them appears to be nothing at all, just water, an absence, a blank space in the geography of the world. But this emptiness is an illusion. If the ocean could be drained away, if the Pacific were suddenly pulled back, the map would change completely. New Zealand would no longer appear as a chain of islands. It would reveal itself as the highest peaks of something far larger. Beneath the waves lies a sprawling landmass, nearly 2/3 the size of Australia. It has mountains and valleys, plateaus and plains. It is a single continuous piece of continental crust, not oceanic rock, but true continent. torn from the ancient supercontinent Gondwana. Around 80 million years ago, scientists call it Zealandia. In Maori tradition, it is known as Te Reu a Maui. It is Earth's eighth continent. And yet, unlike the others, it could not remain above the surface. As Zealandia drifted away from Australia and Antarctica, its crust was slowly stretched. Like warm taffy pulled too far, it grew thinner and thinner. As it thinned, it lost buoyancy. It became heavy. The mantle beneath could no longer support it. Around 23 million years ago, the ocean began to claim it. The valleys flooded first, then the plains, then the hills. Slowly, relentlessly, water erased the land. In the end, 94% of the continent disappeared beneath the sea. A continent drowned. Before it sank, Zealandia was green and alive, a vast raft of forests and wetlands drifting through the southern oceans. Ancient conifer forests, giant ferns, and ecosystems, unlike anything else on Earth, flourished there. Because Zealandia separated from Gondwana before mammals became dominant, it became a refuge for birds and reptiles. It was a place where dinosaurs may have lingered longer than anywhere else. A land where the tuatara, a reptile descended from a lineage older than the dinosaurs themselves, still survives today, on the few peaks that remain above the waves. When ships cross the Tasman Sea, they are not sailing over empty water. They are passing above fossilized forests, buried river systems and landscapes that have not seen sunlight for 20 million years. Zealandia is a ghost continent, a sleeping giant, resting just beneath the keel, waiting in the dark. While Zealandia was lost to the slow, silent rhythms of geology long before human eyes could witness it, other lands vanished within human memory. To find one of the most haunting of these drowned worlds, we travel north to the cold, gray waters of the North Sea, the stretch of ocean that now separates Great Britain from mainland Europe. Today, this sea feels permanent, harsh, industrial, a place of storms, oil platforms, and steel towers rising from the waves. It seems as though it has always been there, but it hasn't. Just 8,000 years ago, a heartbeat in planetary time, the North Sea did not exist. In its place was a land. This land is known as Doggerland. It was not merely a narrow bridge between regions. It was a vast and fertile subcontinent, the true heart of prehistoric Europe. Picture rolling plains, wetlands, rivers, and rich grasslands, stretching unbroken from what is now England to Denmark and the Netherlands. The Thames was not a river flowing into the sea. It was a tributary joining the Rhine to form a massive super river that wound slowly across the land before reaching the Atlantic. This was a place of abundance. Great herds of mammoths, reindeer, and wild horses roamed freely. The soil was rich. The hunting was plentiful. Thousands of Mesolithic people lived here, families who built fires, shaped tools, and raised children, and watched the seasons change on land that now lies 50 meters beneath the waves. We know this not from legend, but from evidence. The sea from time to time gives back what it has taken. For centuries, fishermen dragging heavy nets across the floor of the North Sea have pulled up objects that do not belong to the ocean. They find fossilized mammoth tusks blackened by time, the skulls of woolly rhinoceros, the antlers of giant elk, and sometimes most chillingly, they pull up the tools of people. Harpoons carved from antler, stone axes shaped by human hands, even fragments of human bone. These are not myths. They are the debris of a drowned civilization. Tangible proof that beneath the rolling waves there was once dry land, that where storms now rage, campfires once burned. that entire worlds can vanish, not in fire or explosion, but quietly beneath a rising sea. The end of Doggerland was not a single moment of destruction. It was a slow, quiet apocalypse, one that unfolded over generations. As the great ice sheets of the last ice age began their final retreat, global sea levels rose steadily. Year after year, lifetime after lifetime. The water moved inward almost politely at first. Vast grasslands became salt marshes. Marshes softened into tidal flats. Forests weakened their roots, slowly poisoned by creeping salt. What remained were ghost forests, pale stumps preserved in mud still visible today along parts of the English coast when tides fall exceptionally low. The people of Doggerland did not vanish suddenly. They adapted. They retreated. Families moved toward higher ground, inching east and west, following the slow loss of their homeland. They became refugees of a changing climate. Long before such a phrase existed, drawn toward the hills that would one day be Britain and the lowlands of the Netherlands. But the final blow did not arrive gently. Around 6,200 BCEE, far off the coast of Norway, the seafloor itself failed. A massive section of the continental shelf collapsed in what is now known as the Storegga Slide. An unimaginable volume of rock and sediment surged downward, displacing the ocean above it. The result was a mega tsunami. A wall of water, perhaps 20 meters high, raced across the North Sea. It slammed into the remaining low-lying fragments of Doggerland with overwhelming force. In a single afternoon, coastlines were erased. Settlements were swept away. The last islands vanished beneath the surge. When the sea finally withdrew, it left behind poisoned land and broken ground. Britain was severed from Europe. The heartland was gone. Doggerland slipped fully into memory, preserved only in sediment silence, and the occasional artifact lifted by a fisherman's net from the dark floor of the sea. Far to the south, in one of the most remote and wind-scoured regions on Earth, another drowned giant lies hidden. In the cold expanse of the southern Indian Ocean, halfway between Africa, Australia, and Antarctica, rises the Kerguelen Plateau. On modern maps, only a few jagged peaks appear above the waves, the Kerguelen Islands, often called the Islands of Desolation. They are bleak and treeless, battered relentlessly by circumpolar winds. But these islands are only the highest points. Beneath the surface lies a submerged landmass, 3 times the size of Japan. Unlike Zealandia, which is a fragment of ancient continental crust, the Kerguelen Plateau was born from fire. It is a massive igneous province, a land built by sustained volcanic eruptions from a deep mantle hotspot. For millions of years, lava poured out layer upon layer, constructing a vast plateau in the growing ocean. There was a time roughly 100 million years ago, during the Cretaceous period, when this place was not drowned. It was green. Sediment cores drilled from the plateau tell a remarkable story. Beneath layers of deep-sea mud lie traces of ancient soil charcoal and fossil pollen. These microscopic remains reveal forests' dense stands of ferns and conifers, resembling the temperate rainforests of modern New Zealand or Patagonia. This sunken land was once a living bridge, a refuge, a pathway for dinosaurs and early mammals migrating between India and Antarctica before the continents drifted too far apart. Today, it lies silent beneath kilometers of water, a drowned empire of basalt swept by deep ocean currents. Its only inhabitants now are deep-sea creatures and the lingering chemical ghosts of forests that drowned tens of millions of years ago. The stories of these lost worlds are not merely ancient history. They are warnings. We tend to think of maps as finished things, static, permanent. We draw borders. We build cities along the coast. We lay highways beside the sea, as if shorelines are eternal. But the planet does not recognize our certainty. Land rises, land sinks. Oceans advance. Worlds vanish. The sea remembers. And it will rise again. Geology reminds us of something deeply unsettling. A coastline is not a permanent line. It is a temporary boundary, a moving edge. We are living in what scientists call an interglacial period, a warm pause between ages of ice. But pauses do not last forever. The ice is melting once again, and with it begins a familiar process known as marine transgression, the slow, patient advance of the sea. If we look at the modern world through the eyes of a geologist, we are not seeing a finished map. We are seeing a preview of future ruins. The low limestone plains of Florida, the vast river deltas of Bangladesh and the Mekong, the fragile chains of coral atolls scattered across the Pacific. These are not permanent features. In deep time, they are as fragile as sand castles built at low tide. As the oceans expand, reclaiming water once locked away in ice, these lands will follow the fate of Doggerland. Our cities of glass and steel, gleaming in the sunlight today, will one day rest beneath the waves. Coral will grow through empty windows. Kelp will sway where streets once ran. The ocean is patient. It has claimed continents before. It will do so again. The same water that sustains us is also the water that waits. We build our civilizations along the edge of a sleeping force, hoping it remains still. But Earth's history whispers a quieter truth. What sleeps eventually wakes. Yet water is not the only invisible system keeping our world alive, nor is it the only thing shifting beneath our feet. Far above the atmosphere, stretching thousands of kilometers into the black silence of space, there exists another hidden guardian, a shimmering, invisible shield. This is the magnetosphere. It is a vast bubble of magnetic energy generated deep within the planet by the restless motion of molten iron, churning in Earth's outer core. This magnetic field deflects the solar wind, shattering streams of charged particles that would otherwise strip away our atmosphere, boil our oceans, and sterilize the surface. Without this invisible armor, Earth would resemble Mars, a dry, airless rock exposed to cosmic radiation. We tend to imagine this shield as uniform, stable, unchanging. It is not. Right now, there is a thinning in the armor, a growing weakness known as the South Atlantic anomaly. Stretching from the coast of South America across the South Atlantic and towards southern Africa, this region is a ghost zone, where Earth's magnetic field is significantly weaker than elsewhere. Here, the Van Allen radiation belts dip dangerously low, brushing the upper atmosphere. From the deck of a ship, the sky looks ordinary, calm, blue. But to satellites and spacecraft, this region is treacherous. When satellites pass through the anomaly, they are exposed to intense radiation, electronics malfunction, data corrupts, instruments fail. Even the Hubble Space Telescope is programmed to shut down its sensitive cameras while crossing this region, shielding its eyes from the raw glare of space. This is not science fiction. It is a widening breach, a surface expression of turbulence deep within the planet's core. The molten iron ocean below is restless, and its disturbance is tearing a subtle hole in the sky above us. This anomaly is not an isolated quirk. It is part of a larger pattern. We design our maps, our runways, and our navigation systems on the assumption that north is fixed, reliable, permanent. But magnetic north is not anchored. It moves. For centuries, the magnetic North Pole drifted slowly across the Canadian Arctic, wandering almost lazily. Then in the late 20th century, something changed. The drift accelerated. Today, the magnetic North Pole is racing across the Arctic Ocean, pulling away from Canada and heading towards Siberia at more than 30 kilometers per year. It is moving so quickly that the World Magnetic Model, the mathematical backbone of modern navigation, used by everything from smartphones to submarines, must be updated earlier than planned just to keep pace. The planet is shifting. Quietly. Constantly. Beneath the oceans. Beneath the continents. And even above the sky. And as we drift towards sleep, it is worth remembering this. The Earth is alive, not in a poetic sense, but in motion. Nothing about it is fixed. Nothing is guaranteed to stay where it is. The ground moves. The sea advances, the sky itself can thin. And yet for now the balance holds. For now the shield remains. For now the oceans breathe. For now the planet carries us gently. So rest. Let the slow rhythms of deep time fade into the background. You are here in this moment, safe within a fragile, beautiful balance that is held for long enough to let you sleep. And for tonight, that is enough. But this gentle drift of the magnetic pole is only a whisper of what the planet is capable of. Locked into ancient lava flows around the world is a far more dramatic record. As molten rock cools, tiny magnetic minerals freeze in place, aligning themselves with Earth's magnetic field at that moment. These rocks are memory crystals, and what they remember is unsettling. The poles have not merely wandered, they have flipped. Hundreds of times over Earth's long history, the magnetic engine at the planet's core has fallen into chaos. The simple dipole. A clear north and south collapses. The field weakens to a fraction of its strength. Multiple temporary poles can appear across the globe. North becomes south. South becomes north. This is known as a geomagnetic reversal. The last complete reversal occurred nearly 780,000 years ago. But smaller disruptions, called excursions, have happened more recently. One of the most dramatic was the Lachaume event, around 42,000 years ago, when the magnetic field weakened to just 5% of its current strength. For a time, the shield nearly vanished. We do not know exactly what a full reversal would feel like from the surface, but the models are haunting. This would not be a sudden flip like a switch. It would unfold slowly over centuries, perhaps millennia, as the field fractured and reassembled. During this transition, the sky itself would change. Auroras, now confined to polar regions, would spill across the globe. Curtains of green and red light would ripple over deserts and rainforests, alike over the pyramids, over the Amazon, over oceans and cities. It would be a moment of terrible beauty and profound exposure. With the magnetic field weakened, Earth would stand more open to the sun's raw output. Solar storms would penetrate deeper, radiation levels would rise, the invisible walls would thin. The growing weakness over the South Atlantic may be an early tremor, a sign that the molten iron ocean deep below is already rearranging itself, quietly preparing the machinery for another great shift. While we watch the sky with unease, we remain largely unaware of another world entirely, one that lies beneath our feet. For most of human history, life was thought to be a surface phenomenon, a thin green film clinging to the crust, dependent entirely on sunlight. But in recent decades, deep drilling projects and mines, descending kilometers into Earth, have revealed a startling truth. Life does not stop at the surface. It goes down, deep down. Scientists have extracted core samples from several kilometers beneath the ocean floor, solid basalt rock, sealed away for millions of years, and found it alive. Not metaphorically, literally. These are not creatures of light. They are intraterrestrials, bacteria and archaea, living not in caves or underground lakes, but inside microscopic, fluid-filled pores within solid rock. They exist in total darkness, under pressures that would crush steel, and at temperatures that would boil water at the surface. This hidden realm is known as the deep biosphere. Its discovery has rewritten our understanding of life on Earth. Estimates suggest that this subterranean ecosystem may contain more total biomass, more living matter than all plants, animals, and humans on the surface combined. Earth is not merely a rock with life on it. It is a rock that is alive. A planet permeated by biology, threaded with living systems, extending miles into the crust. But life down there follows different rules. On the surface, life is fast, competitive, urgent. A bacterium can divide in minutes. Ecosystems surge and collapse in seasons. Energy is abundant, flowing freely from the sun. In the deep biosphere, energy is scarce. There is no sunlight, no fresh organic input. Life survives instead on faint chemical gradients, the slow release of energy from cooling rock, or the gentle decay of radioactive elements like uranium in the surrounding stone. Because energy is so limited, time itself stretches. These organisms live in extreme slow motion. A single cell may divide once every 100 years, or 1,000, or perhaps once in 10,000 years. They exist in a state that blurs the line between life and dormancy, metabolically active, yet almost frozen in time. They are living statues. They have persisted for millions of years, sealed inside stone, indifferent to mass extinctions, indifferent to ice ages, indifferent to the rise of humanity. To them, the chaos of the surface is little more than a passing ripple. They are the planet's quiet majority, the dark matter of biology, patient, waiting, holding their place deep within the rock as the world above changes again, and again, and again. The existence of this vast hidden history leads us toward a question that feels almost like science fiction. And yet it is a question asked not by dreamers or conspiracists, but by serious climatologists and astrophysicists. It is known as the Silurian hypothesis. At its heart, it asks us to confront a blind spot in how we understand time. We tend to assume that we are the first. We look at our cities, our machines, our satellites, circling the planet, and we imagine ourselves as the singular peak of intelligence on Earth. But the planet itself is 4.5 billion years old. Industrial human civilization has existed for only a few centuries. On the scale of deep time, that is almost nothing. The hypothesis poses a simple but unsettling question. If an advanced industrial civilization had existed on Earth millions of years ago, long before humans, would we know? If a reptilian species during the Triassic or an early mammal in the Paleocene had built cities, burned fuel-shaped art, and altered the climate, would any clear trace of them still remain today? Our instincts say yes. We look at monuments, the pyramids, the Great Wall, the dense towers of modern cities, and we feel they are permanent. We imagine that we are carving something indelible into the planet itself. But to Earth, our civilization is only a surface texture. The planet is a recycling machine of extraordinary efficiency. Let the thought experiment run. Imagine that humanity vanished tomorrow. What would remain? Within a few centuries, steel would corrode, skyscrapers would rust, weaken, and collapse. Concrete, stripped of its reinforcing metal, would fracture and crumble back into sand. Within a few thousand years, forests would return. Roots would pry apart foundations. Soil would bury what was left. And the erasure would continue. Over millions of years, tectonic plates would shift. Continents would fold and stretch. Mountains would rise and be worn flat again. Glaciers would grind landscapes down to bare stone, scraping away any trace of what once stood there. Even the fossil record, the archive we rely on so heavily, is incomplete. It is not a library. It is a scattered, damaged book. We possess fossils of dinosaurs. Yes, but they represent only a vanishingly small fraction of the life that ever lived. The chance of any specific species being preserved is close to zero. If a technological civilization lasted for 10,000 years, the entire span of human history so far, it would appear in the geological record as a layer no thicker than a sheet of paper. It would blend seamlessly into the background of natural events. Empires do not survive deep time, so if buildings, machines, and monuments dissolve into dust, what remains? How would we ever detect a ghost civilization? The scientists behind the Silurian hypothesis suggest that we are looking in the wrong place. We should not search for objects. We should search for chemistry. A technological civilization leaves behind a distinct chemical signature, the same one we are imprinting on the planet right now. Burning vast amounts of fossil fuel alters the balance of carbon isotopes in the atmosphere. Lighter carbon, carbon-12, is released, absorbed by the oceans, and locked into sediments. Millions of years from now, future geologists will not find our cities. But they will find this signal. They will see an abrupt spike in carbon isotopes. They will detect a sudden, unexplained warming in the planet's climate record. They will find layers containing strange materials, plastics, synthetic chemicals, molecules that do not occur naturally and do not decay easily. They may even discover traces of radioactive isotopes like plutonium-244 substances that do not exist without nuclear processes. These are the true fingerprints of industry. They are subtle, they are chemical, and they are almost the only things that endure. Everything else fades. Stone becomes dust. Steel becomes rust. Civilizations become numbers in a graph, brief disturbances in an otherwise quiet planet. And as you rest now, letting these thoughts drift gently past, there is no urgency in them, only perspective. We are not separate from Earth's story. We are a moment within it. A thin layer, a brief warmth, a whisper written in chemistry. And, like everything else the planet has carried, we too will one day pass quietly into the deeper flow of time. So let your thoughts slow. Let the long rhythm of the earth take over. You do not need to solve these questions tonight. You only need to rest within them. This is where the idea moves beyond a simple thought experiment and becomes something more intriguing, a genuine mystery. When we look carefully into Earth's deep past, we do find irregularities. Events that at a distance resemble the signals our own civilization is leaving behind today. The most striking of these is known as the Paleocene to Eocene thermal maximum, the PETM. About 56 million years ago, the planet experienced a sudden and dramatic warming. Global temperatures rose rapidly, the oceans became more acidic, and most telling of all, an enormous amount of carbon was injected into the atmosphere in a relatively short span of time. The prevailing explanations are natural. Massive volcanic activity, the release of methane, hydrates from the seafloor, These mechanisms are plausible and they are likely responsible. And yet the data is imperfect. The rate and magnitude of the carbon release during the PETM are uncomfortably similar to the pace at which we are altering the atmosphere today. No one is suggesting that an ancient civilization caused this event. That is not the claim. The lesson is quieter and more humbling. The Silurian hypothesis reminds us that deep time erases certainty. We cannot prove that no technological civilization ever existed before us. The rock record is not complete enough for absolute statements. Civilization, in this view, may not be a straight ascent, but a recurring fever, a disturbance the planet absorbs, recovers from, and eventually forgets. The silence of stone may not be empty. It may simply be hiding the exhaust of something long gone. But Earth does more than preserve faint chemical echoes. It is also, in its own way, speaking. Most of the time we do not hear it. Our attention is filled with wind engines, voices, and the constant noise of human life. Yet, for decades, reports have emerged from quiet places, deserts, coastlines, rural valleys, describing a strange phenomenon, a sound. It is called the hum. Those who experience it describe a low, steady vibration at the edge of hearing, like a distant engine idling behind walls, like a massive machine running somewhere far below. It passes through buildings. It lingers at night. It is felt in the body more than heard with the ears. For years, it was dismissed as tinnitus or imagination, but evidence has slowly accumulated. The hum appears to be real. It is now thought to arise from the planet itself, a result of the immense energy of ocean waves striking continental shelves. These impacts generate tiny seismic vibrations that travel through solid rock. The Earth quite literally rings, at frequencies so low they slip beneath conscious hearing. The planet is always trembling, always moving. There is another rhythm as well, one that does not come from the ground but from the sky. Between the surface of the Earth and the electrically charged ionosphere above, it exists a global electromagnetic cavity. Like the body of a musical instrument, it resonates. Every second, hundreds of lightning strikes act like mallets striking this invisible bell. The result is a standing wave that wraps around the planet. This is known as the Schumann resonance. Its fundamental frequency is about 7.83 hertz, a constant planetary pulse that has existed for as long as Earth has had an atmosphere. And here a quiet coincidence emerges. That same frequency, around 8 hertz, corresponds to the alpha and theta rhythms of the human brain, the states associated with calm attention meditation and the threshold of sleep. We evolved within this electromagnetic field. Our nervous systems developed while bathed in this rhythm. We are not isolated from the planet's subtle signals. In a very real sense, our biology is tuned to Earth's atmospheric pulse. This does not mean the planet is thinking, but it does suggest a deep resonance, a harmony between life and the systems that sustain it. As we reach the end of this long journey, the separate pieces begin to settle into a single image. We have followed the water that moderates temperature, the magnetic field that guards the atmosphere, the deep biosphere that fills the crust with hidden life, the cycles of destruction and renewal that erase and rebuild the surface. Seen together, the Earth no longer resembles a lifeless rock. It behaves more like a system, self-regulating, responsive, and resilient. This perspective is known as the Gaia hypothesis. It does not claim that Earth is conscious in the human sense, but it proposes that life and environment are inseparable, that oceans, air, rock, and biology form a single interacting whole. A planet that maintains conditions favorable for life, not through intention, but through feedback. through balance, through time. And as your thoughts begin to slow, you do not need to hold all of this in your mind. Let the ideas drift like clouds. Let the rhythm soften. You are part of this system, carried by water, shielded by magnetism, synchronized in subtle ways with the quiet pulse of the world. For tonight, that is enough to rest within. Let the planet keep turning. Let the hum fade into the background and allow sleep to arrive gently as it always has. It suggests that Earth is not a collection of separate parts, but a single self-regulating system, one that quietly maintains the conditions necessary for life. Much like a living body, it balances its own temperature and chemistry. Volcanoes act as vents, releasing excess heat. The oceans circulate like blood. The atmosphere breathes as lungs. The magnetic field forms a protective skin. And perhaps we are something new, the first elements of this vast planetary body, capable of reflection. The moment when the system begins to observe itself, we are in a sense how Earth comes to know itself. We began this journey by asking where the water came from. And we found that it is a cosmic traveler forged in ancient stars, carried through fire, shaped by gravity, and preserved across unimaginable spans of time. But in following the water's path, we did not just uncover the history of the planet, we uncovered ourselves. The atoms in your body once drifted through space, locked inside the rock that delivered the oceans. The salt in your blood carries the memory of the first seas. The electrical rhythms in your brain echo the lightning that has always danced through the sky. We are not passengers on this world. We are the world briefly arranged into thinking, breathing forms. The history of Earth is not something that only happened long ago. It is unfolding right now inside you. You are not separate from the story. You are its current chapter. You are the planet remembering itself through living matter. And now the journey can come to rest. The cycle is complete. The water has fallen from the sky. It has carved the land, and it has returned once more to the deep. The lost continents sleep beneath the waves. The hidden life waits patiently in the stone, and the planet hums its low, steady lullaby. You can let go now. You belong to this vast, resilient, and beautiful system. The Earth has held you since the moment you arrived, and it will continue to hold you through the night. The silence around you is not empty. It is full of life, of memory, of deep time and distant stars. Let the rhythm of the planet carry you. Let the long story wash gently over you. Good night.